Hi guys, today we're going to cover section 2.5, graphs with equation and circles. So if you look at things to know, now some of the stuff are the things that we've been doing for a while. Finding x and y intercept of any graph. So these will work for any kind of a function that or equation that we have. So it's not a big deal. We'll definitely do some example of that later. Familiarize yourself with the symmetry test, x and y axis and origin. That you can be found in the book, and we're not gonna talk about too much in here. So I just want you to read it and just know it's there for now. But definitely in chapter 3, we're gonna really go into a lot of details and theory behind it. So just kind of make sure put an asterisk and keep it in mind. That will be on page 250. And today we're gonna spend more time on the center, the circle, and graphing a circle and whatnot. Okay, so let's get going. All right, for number 2, find the x and y intercepts of each graph algebraically. So first one, you got y equal x minus 3 squared plus 2. And we know from the previous to find x and y intercepts. If you want to find the y-intercept, you let x equal to 0. And if you want to find the x-intercept, you let y equal to 0. Okay, so let's go ahead and do that over here. So y equal x minus 3 quantity squared plus 2. I'm going to let x equal 0, so y equal 0 minus 3 quantity squared plus 2. And this will give me 3 squared plus 2, which is 11. Okay. And to find the x-intercept, right, we're going to let y equal 0, so you get y equal x minus 3 quantity squared plus 2. Solve and minus 2 on both sides. You get negative 2. Excuse me, and that's 0. Sorry, 0 over here. You get negative 2 equal x minus 3 squared. And here is our problem. If we square root both sides like we're supposed to do, you get plus minus square root of negative 2. Okay, and this right here means there is no x-intercept, because when we're trying to graph it, right, because it's a point, x-intercept is a point, I can't graph a imaginary number using a real number axis. Okay, so in this case, not available, and that's it. Okay, and this will, later on we're going to look at other equations, finding x and y intercepts. This idea is never going to go away. All right, letting x equal to 0, y equal to 0, this is going to be with us for a while. So make sure you know how to do that. Okay, next question. Y equal x plus 2, x minus 5. So let x equals 0. You get y equal 0 plus 2 times 0 minus 5. This is 2 times negative 5, which is negative 10. Now, if you let y equal to 0, right, you get 0 equal x plus 2, x minus 5. And I think we've done enough of these questions. You know what's coming up next. X plus 2 equal to 0, or x minus 5 equals 0. So x equal negative 2 or 5. So in this case, we actually have 2 x-intercepts. So these are x-intercept. This right here is y-intercept. Okay. All right. And the last one, we have y equal negative x squared minus 8x minus 15. So if make our table here, if I let x equal 0, you get y equal negative 0 squared minus 8 times 0 minus 15. So y equal negative 15. If you let y equal 0, you get 0 equal negative x squared minus 8x minus 15. I think this is factorable, but I'm gonna do a really quick sign switch by multiplying everybody by negative 1. So you get 0 equal x squared plus 8x plus 15. And I think this is a lot easier to see. This is 0 equals x plus 3, x plus 5. So that means x plus 3 equals 0, x plus 5 equals 0, and x equal negative 3, x equal negative 5. Okay, so again, this problem has two x-intercepts and one y-intercept. All right, and hopefully with these three questions, you notice I gave you the quadratic equation in three different forms. The part A is what we call the vertex form. Right, and you would finish that problem when you're solving for x using the square root property. Part B is what I call a factor form. Right, notice things are already factored. So you would use the zero product, right, or the zero factor theorem, depending on what the book says. Right, set individually equal to 0 and solve. Part C, that's our standard form. Right, so, and notice, standard form is really easy to figure out what the y-intercept is, because when you plug in zeros, all the x's drop out. Okay, and that problem, standard form, can be solved using quadratic formula or factoring. Right, you have to use quadratic formula if factoring is not possible. Okay, so hopefully this will give you three different things to think about, and hopefully you can recognize them all and use the best method when time comes to solve and stuff. All right, we're gonna move on to the circles. Now, there's the formula you want to focus on the circle is this: x minus h quantity squared plus y minus k quantity squared equal r squared. Okay, this formula tells you about the center of the circle, which is h and k, and the radius, which is r. Okay, so in this case, if you have x plus 2 quantity squared plus y minus 7 quantity squared equals 64, what I would do is I would try to make this formula look like this, even with all the symbols and everything. So instead of x plus 2, I'm going to write it as x minus negative 2 plus parentheses y minus 7. I don't need to rewrite anything there because that's already a y minus k. Instead of 64, I recognize, hey, that's 8 squared. Okay? So once you have rewritten the formula, then we can figure out what's our value for h, k, and r. So in this case, the h is negative 2. The k is 7. And the r is 8. So the center of this circle happens at negative 2, 7. And the radius of that circle is 8. Okay. Same idea for part B. X squared plus y plus 4 squared equals 30. Okay. So let's rewrite the h and k first. the x is the same as x minus 0. Right? X equal x minus 0. That should be something we can agree on. Plus y plus 4, I had to rewrite it as y minus a negative 4. So this is y minus a negative 4. And that's going to equal to 30. Sorry, I ran out of space. I'm going to write it a little bit better. So repeat it again. X minus 0, quantity squared, plus y minus a negative 4, quantity squared, equal. Now, I know 30 is not a perfect square, but we're in Math 110, so we're just going to deal with the non-perfect squares. So this is going to be square root of 30 quantity squared. Okay, so our center, the h and k, is going to be 0, negative 4. Right? Because this is my h, this is my k. Radius, this is going to be square root of 30. Alright? The square root of 30. Okay. So, yes, there might be time you're going to get a radius or a center that are not nice numbers. We're just going to deal with it. So, that's the best way I can say about this is just deal with it. Alright. Now, let's move on to number 4. Number 4. Write the equation of a circle in standard form given the center of the rate and the radius. Okay. So when I say the standard form, they're talking about the x minus h quantity square plus y minus k quantity square equal r squared. Okay, that's the standard form they're talking about. So from here, we have the center and the radius. If we are given a center and radius, all we gotta do is plug it in. And then we're done. Okay? So with the center being negative 3, 4, and the radius equals square root of 21, I'm just going to plug them in. So I have x minus negative 3 quantity squared plus y minus 4 quantity squared equal square root of 21 quantity squared. Once we plug them in, and we're going to reduce a little bit. Not completely reduce, but just want to kind of keep things simplified a little bit. This is going to be x plus 3 quantity squared plus y minus 4 squared equal square root of 21 squared. The square and square roots cancel out, 21. That's all you gotta do. You don't have to FOIL, you don't have to do nothing. Okay? Just clean it up, plug it in and clean it up. Okay? Part B, same idea. You got 0, negative 1/2, and you have radius is square root of 7 over 5. So let's start by plugging all the numbers. X minus 0 quantity squared plus y minus a negative 1/2 quantity squared equals square root of 7 over 5 quantity squared. Okay. X minus 0, you can just write it as x squared, doesn't matter. Plus y minus minus, so that becomes a plus. So y plus 1/2 quantity squared. Radius squared, square root of 7 over 5. When you square a fraction, you square the top and bottom. So this is square root of 7, which is 7, and square of 5. Right, 5 squared is 25. So we're done with that one. Okay, it's pretty straightforward. If they give you the center and the radius, plug it in, simplify a little, and you'll be good. All right. Now, the issue we're going to have is number 5. Number 5, what they gave you is, if you take the standard form and multiply everything out, what you get is part A and part B. Okay? So what we have to do is we're going to have to bring everything back. And the only way to do it is by completing the square. So let me show you how to do part A. So part A, you get x squared plus y squared plus 4x minus ay equal to 5. Now, we did a little bit of complete the square from the earlier sections, so same idea here. I'm going to kind of rearrange things a little bit, moving things around. So x squared plus 4x plus the missing number goes with it, plus y squared plus, minus 8y plus the missing number goes with the y, equal 5 plus the missing number from the x. I can probably color code them. And that. Okay. So if you look at it, for x squared plus 4x, if I want to complete the square, I need to take this 4 divided by 2, then square it. Okay, that's our trick. Reason I can do that, because the number in front of x squared is 1. Okay, that only works when number in front of x squared is 1. So take that half of the 4 and then you square it. This time you still get 4. So we're just going to put 4 here. But whatever you add to one side, you also got to add to the other side. Don't forget. Okay? Alright. Same thing for the y's. I'm going to take half of negative 8 and then square it. And that's what I'm going to add to the other side. So this is negative 4 squared, which is 16. So I have to add 16 to here and here. Okay. Now, once you have completed the square, we're going to factor the x and the y's. Right? X squared plus 4x plus 4. This is x plus 2 quantity squared. Okay? You can get this number fairly easy by looking at this number. They're identical. Always. Okay, now for y, this is going to be y minus 4 quantity squared. Why? Because that. Equal 5 plus 4 is 9, 9 plus 16 is 25. Okay, so at the end of the day, what we have is x plus 2 quantity squared plus y minus 4 quantity squared equals 25. And our center is negative 2 comma 4. Our radius is 5. Okay, you have to complete the square twice, right? And add a missing number on both sides. Okay, next one. Next one, you have 3x squared plus 3y squared plus 6x plus 30y equal negative 3. Okay. So earlier we said that the only way to do complete the square is if the number in front of x squared is 1. So what I'm going to look at is I have 3, 6, 30, and negative 3. I can probably divide both sides by negative 3. Divide both sides by 3. Okay, so if you do that, everybody gets divided by 3. You get x squared plus y squared plus 2x plus 10y equal negative 1. Okay. Now this problem just looks like the previous. Rearrange. X squared plus 2x plus blank plus y squared plus 10y plus blank equal -1 plus red blank plus missing numbers. Okay. Alright, x squared plus 2x. The missing number is 1 because 2 over 2 squared is 1. Y squared plus 10y plus the missing number. That missing number is going to be 25 because 10 over 2 quantity squared is 25. So I'm going to add 1 here and 25 here. And this actually turned out pretty decent. On the right hand side, I get a 25. On the left hand side, I have this and I have that. X squared plus 2x, that's x plus 1 quantity squared. Plus y squared plus 10y plus 25, that is y plus 5 quantity squared. So in this case, our center is -1, -5, and the radius is 5. Okay. Alright. Okay, so now let's, I know I didn't say graphing the circle, but let's go ahead and graph anyway. So we can actually, so you'll see it's actually pretty straightforward. The center is -1, -5, and the radius is 5. So let me keep that in mind before I forget. -1, -5, and 5. -1, -5, and 5. Okay. So all I have to do is this. I'm gonna draw my x's. -1, -5. So starting origin, -1, 1, 2, 3, 4, 5. Now, if my radius is 5, that's actually really easy. I am going to just start at my center. I'm going to go up 5, down 5, left 5, and right 5 from center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I can connect the dots. Now mine doesn't look like a circle, but I'm not going to grade you on your artistic abilities. Okay, but at least draw a semi-respectable circle. Okay, but all you need is the center, the points on the above, below, left, and right. Okay, those are the 4 easiest points to get. So if you got those 4 points, I'm perfectly happy. Okay. All right, so this is it. Again, we'll talk more about the symmetry stuff. I just wanted to make sure you're at least aware of it. Focus more on the center of the circle, the radius of circle, and how to convert from general form to standard form. And I think you should be okay. All right. Have a good day. I'll talk to you guys later. Bye.